Welcome, my dear JEE 26 warriors, the class 12 syllabus on full speed. And we are on to the next topic of us, which is capacitors with dielectrics, also the energy stored and the energy density in a capacitor, and also the combinations like series, parallel, and along with the dielectric combinations of capacitors. All of this with detailed theory right from the scratch till the PYQ level with me, your mentor, your guide, your captain, and that is none other than your Capto Shreyas. This is your physics master teacher, and I have been training mentoring kids for more than 13 plus years. And here you are with my, the next batch, hoping to clear the JEE Advanced and the JEE Mains entrance examination with flying colors. And I'm pretty sure if you maintain this consistency and this pace, 100% you will crack it, just like my last year students, right? So last year too, we had amazing results like All India rank 15 in JEE Advanced. Students who did extremely well in JEE Mains with 99.99 percentiles, and almost half the batch clear the JEE Mains examination. That's a very good ratio that we have at Vedantu. So with all of these amazing results and the best quality education, I'm pretty sure your confidence will come up to the next level. And if you've forgotten to like this video, please do that right now. You need to be reminded. So please do it. And yes, if you've forgotten to subscribe to the most amazing #1 JEE English channel in the country, Vedantu JEE English, please do it right away, right now. In the previous session, we have seen what is a capacitor, what is capacitance, everything, right? And it was a beautiful class. And I have shown you some simulations, and we have also derived the different types of capacitance for parallel plate, cylindrical, and also spherical. Yeah, like this video, the PDF will be shared in the description box as well as in the comment section. Homework answer is also there in the PDF, so please check it out. All right, and if you are interested to join our Sigma batch, the link is also there in the description box, which is a very affordable batch in pure English with the complete 11th and 12th syllabus coverage by October, and revision will follow with test series and mock tests and study material. Everything is there. The batch has just started. Still, it's not late. Make sure you enroll now and make sure that you are studying in a proper systematic manner with tests and study material, right? Okay, so let's begin, my dear warriors. And hello, Virat. Hey, Mitra, Akhil. Welcome, TN, Satya. Hello, Anime. Hello, Pavitra. Hi, Dev. Good evening. Hi, Veda. Hi, Pavi. Nice to see you all out here. Yes. Good evening. I have two doubts. First, which chapter has the highest weightage? Nobody knows. Second of all, what is the qualifying marks in JEE Mains to write JEE Advanced? The weightage changes, in the last couple of years, but you cannot really predict which is high weightage, which is low weightage, but you can say which are important chapters. Like the entire of mechanics is important from 11th till simple harmonic motion, rotational motion, system of particles. And in 12th standard, electrostatics chapter, the entire Gauss law, everything, capacitors, and current electricity. And lastly, ray optics. These are the major things. But modern physics is also there. So variations are there every year and in every shift. So really you cannot predict, but majorly these are very important. Okay. And of course, for qualifying marks, it depends. You should definitely be above 100, but out of 300, on the safer side, let's say you are above 120, 130 marks, for sure you will be writing the JEE Advanced examination. So on the safety side, take it as 130 marks. I know 130 is a lot, but I mean, on the lower side, it is a lot. Otherwise, it is not a lot. So that is what you should target if you just want to write JEE Advanced. All right. So let's talk about capacitors storing energy. Just before this, we had spoken about that, hey, capacitor stores a charge. The charge stored on a capacitor is Q, capacitance is C, V is the voltage. This is basically the charge which has been stored. This is the charge which has been stored. This is the potential difference on the capacitor. This is the potential difference on the capacitor, and C was nothing but our capacitance. C was nothing but our capacitance. So if this is one terminal, this is one plate, this is another plate, this is another terminal, so there will be some positive Q charge here, negative Q charge over here, and this is how the charges get stored on the plates of the capacitor. When you use this capacitor in some circuit, the charges will start moving around, it will develop a current and it will lose the charge and eventually it will become discharged. So all the energy stored will be utilized in that external circuit, maybe a bulb, maybe a motor, anything, doesn't matter. So there is some energy stored here and it gets utilized when you connect a circuit across it. So say for example, you connect some kind of a bulb, motor, whatever, fan, anything, washing machine, some hair dryer, anything. So current will begin to flow and this will definitely get discharged once the circuit is complete. So in a capacitor, so I can say in a capacitor, in a capacitor, in a capacitor, there is electrical potential energy, electrical potential energy which is stored, electrical potential energy which is stored within the electric field between the plates of the capacitor, between the plates of a capacitor, between the plates of a capacitor. Wherever there is field, there is potential, and when there is a charge in the potential, there is energy stored which is electrical in nature. So the electric field obviously creates electrical potential energy which is stored in that capacitor. Outside the capacitor, there is no electric field, so there is no energy stored outside. All that energy is within that volume of that capacitor itself. How much exactly is this particular energy? That's what we need to calculate. Okay, so here is what we do. Let's basically assume at some instant, the charge is Q, the capacitance will be staying constant, the voltage is V. So both of them will change as the charge increases, the voltage across it will keep on increasing, and slowly as the charge builds up, after a long time, or let's say after some time, after some time, the final charge will be Q and the final voltage, let's say, will be V. The final voltage will be, let's say, V. So this is small v, this is capital V. So this is basically, when it is already charged. This is already charged. Q is in between. So from 0 coulomb, it will go to maybe 0.1, 0.3, 0.5, 0.7, like that. Maybe it will eventually reach 5 coulombs. So 5 coulomb is the final charge. Intermediate values are some variable which is Q. Initially, the voltage might be 0 volts. Slowly, the voltage will start building up and eventually the voltage will reach the final voltage across those terminals as the charge begins to build up. So if you see the different instances of that particular capacitor, if you see the different instances of the capacitor building up the charge, it will look something like this. Initially, there will be no charge over here. Then there will be some random charge which will keep growing. And eventually, there is this plus Q and minus Q charge over here. This is at some instant. This is completely uncharged. This is uncharged capacitor. This is uncharged capacitor. This is completely charged capacitor. This is while it is getting charged. So while it is getting charged, this is the diagram. Till this point, everybody clear about this? Okay, everyone? All right, Zoro, don't spam, man. Yeah, I'm very good. And oh, your name is also Shreyas Srinivas. Oh my God. Hi, Fachi69. Nice to see and know that. That's great. Hi, Devakar. Glad I was able to clear your doubts. Okay. Right. Okay. Now, imagine there is a small change in the energy stored in the capacitor. Why will that small change in energy come? Because you have done some work while storing the charge. So during the charging process, if there is a small change, if there is a small change in the potential energy stored, what will that be? It will be basically that energy stored will be because some charge has been stored on that capacitor, some extra charge has been stored. So some work needs to be done. So it is basically that small work done to add some charge on it, to add some charge on it. So the small change in the potential energy is du. U is the symbol for energy. Du is the small change in the potential energy, will be the small work done, which is nothing but dw. But in electrostatics chapter, if you recollect, the work done to move a charge, the work done to move a charge across some voltage is the charge into the voltage difference. So this work done will be that small charge which you have moved multiplied by the voltage difference. Multiplied by the voltage difference. Is this absolutely clear? Sorry guys, yeah, 1 second. There was a small disturbance. Yeah, dq multiplied by v. Yes. Is this absolutely clear, everyone? So charge multiplied by the voltage. So you take some dq charge and put it on the other plate. You increment it by dq and you have some voltage difference v. So that will be the work done. But I have just seen that this particular voltage, this voltage that you see is this voltage, which is nothing but the charge at that instant divided by the capacitance. The charge at that instant divided by the capacitance. I have a feeling I need to integrate this. So if I integrate du, if I integrate du, on the right hand side also 1 by c is on the outer side. It's a constant, that's why. So q into dq over here. Now the limits of the integration are very important. See, initially there will be no charge at all. So when there is no charge, there is no energy. So q is 0, u is also 0. But when this charge becomes capital Q, then the energy stored becomes capital U. So what happens when you do the integration? So let's have a look at it carefully. On the left hand side, it will be U only. So upper limit minus lower limit, 1 by C as it is. X dx integration, x raised to 1 dx integration will be x raised to 1 plus 1 by 1 plus 1, which is x square by 2. So this will be q square by 2. So that means I should put capital Q square by 2 minus 0 square by 2 over here. Yes, everybody with me? Q raised to 1's integration is Q raised to 2 divided by 2. First you will put upper limit, then you will put the lower limit. Okay, so therefore, what will this become? U is equal to, this is 0 only, so it will be half Q square divided by C. Perfect. So half Q square by C is one of the ways of writing the energy. But there could be obviously multiple ways, like say for example, one person decides charge is nothing but capital C into capital V, capital C into capital V, capacitance into final voltage. So this whole square divided by C. So this will become half C square V square by C. One of the C's will get cancelled. So obviously I will get the energy as half C V square. CC gets cancelled, half CV square. So half Q square by C or half CV square, both of them are fine. I can also then write this down as half CV multiplied by V. What is CV? CV is nothing but the charge. So I can also write this down as, charge multiplied by the final voltage. All of these are the same things but different ways of writing them. Whether you write half charge square by C or half CV square, or you write half charge into voltage. One and the same thing. Okay, everyone, like you might have learned this in 10th standard in current chapter. Power is V squared by R, I squared R. It's just different ways of writing it. Or centripetal acceleration, V square by R, omega square R. Same thing. It's just different ways of writing it. Absolutely clear? So half CV square, half Q square by C, or half QV. Okay, fair enough. But like I said before, that this energy is stored in the electrical form in the electrical field between the plates of the capacitor. So how much energy is stored per unit volume? So in the space between that capacitor, per unit volume, how much energy is stored? So that gives me the next term, which is called as the energy density, which is nothing but the electric potential energy, electric potential energy per unit volume, per unit volume. That's it. So that is your energy density. So how do you find this particular term out? Usually the symbol for energy, or usually the symbol for density is rho, but since we are talking about energy, which is potential, so I will use rho u, because density could mean mass per unit volume or so many other kinds of density. Since we are talking about energy is density, so density of energy, so u is the subscript over here. If you ask me what is the unit of this, I mean, look at it. On the top, you have joule, which is energy, and below you have volume, which is nothing but meter cube. So joules per meter cube is the unit of the energy density which is there. Okay. So how much is this energy density going to be? Well, not a big deal to figure it out. So energy stored, sorry, the energy stored in it is nothing but half Q square by C, and the volume of that capacitor, keep this in mind. See, your capacitor was maybe like this. Capacitor was maybe like this, and of course the energy is stored between the plates of the capacitor like a sandwich. Yeah, I hope you can visualize this. It could be your mayonnaise, it could be your chutney, it could be your, I don't know, sauce, whatever. These are like two bread pieces, and in between that your fillings are there. So as you can see, this separation will be nothing but D, and the area of the plates will be nothing but A. So what will be the volume? That will be nothing but area into the width. It will be nothing but area into the width. Okay. But capacitance formula, I already know it. So I can definitely substitute it. So half Q square, I'll see about it later. And I will also put 1 by AD over here. What is the formula for capacitance? Capacitance. It is nothing but epsilon naught A divided by D. Epsilon naught A divided by D. Best part, D and D just got cancelled. So I am purely left with, I am just purely left out with, check this out, half Q square is there. I also have epsilon naught, and I also have A square over here. Half Q square by epsilon naught A square. This is ringing a bell in my head. I remember something like Q by A epsilon naught somewhere. If you recollect, that was the electric field formula. So in the next step, what I will do, I will just write it as half. Instead of putting one single epsilon, I will put epsilon square, and to balance it equality, I will multiply also by epsilon naught. So it will look like this, half Q square by epsilon naught square, A square, and epsilon naught. If you cancel epsilon naught, obviously you will get back this answer. Nothing wrong in it. Now what is this? Guys, try to recollect. Electric field between the plates of a capacitor. Electric field between the plates of a capacitor was sigma by epsilon, which was charge by A and then epsilon. So technically speaking, this Q epsilon naught by A is electric field. So this is nothing but electric field's square. This is the square of the electric field, if you notice it carefully. Is that right? And half is there absolutely as it is, and this is over here. So I've got my energy density formula. It is half epsilon naught electric field square. This same electric field I have put over here. Okay, this entire thing is nothing but E square, if you notice carefully. So energy density is half epsilon naught E square. Epsilon naught being permittivity, E being the electric field. So the density of the energy is proportional to the square of the field. Field becomes double, the density of the energy becomes 4 times. Field becomes 3 times, density of the energy becomes 9 times. That is what it is. Okay? So energy density of a stored capacitor. And this can be used anywhere, guys. So also remember something like this. Maybe the electric field is non-uniform. Electric field is non-uniform. Okay. Here also you can think of small volumes like this, unit volumes. Okay. Over here versus over here. Here the density will be less. Here the density will be more. So more dense energy, and here you will have less dense energy. In fact, if you take a point charge, and I know the electric field due to it will be radially outwards like this. So you will get a radial field. You will get a radial electric field. And let's say somebody decides, okay, I'm at some distance r from it. Okay, I'm at some particular distance r from it. So at this point, how much is the energy density? So, well, at this particular point, if you calculate the energy density, it is half epsilon naught electric field square. But electric field due to a point charge is simply given by, what is this electric field given by? It is given by 1 by 4 pi epsilon naught charge divided by r square. But I have to square this also. So what happens is the energy density will become, okay, so this will be half epsilon naught, and here you will have 16 pi square epsilon naught square, and here you will have q square, and this will be r raised to 4. Best part is the energy density is inversely proportional to r to the power 4. So as you are going away, the density of energy is inversely related to the 4th power of the distance, very rapidly decreasing. This kind of question was also asked in one of the previous years, where you have to figure out how or what was the power of the distance to which energy density is proportional to for a point charge. Right? I hope this is absolutely clear. Hi Bala, welcome. Yes, Chanit. Yes, Pavi, clear, absolutely. Perfect. So let's solve some questions coming up on your screen. The potential of a capacitor having 6 microfarad capacity goes from 10 volts to 20 volts. What is the increase in the energy? Capacitance is given and voltage is given. So the correct formula over here out of these three, because capacitance and voltage is given, I believe I will use this formula. Charge is not given, so why to bother about these two? So I'll use half CV square formula. So let's use half CV square. So they have asked what is the increase of the energy. That means delta U. That means final minus initial energy. Final energy will be half, capacitance is same, final voltage square minus half capacitance, initial voltage square. So half C is basically common, and we have final voltage square minus initial voltage square. So capacitance, how much is it? It is 6 micro. So 6 into 10 to the power minus 6. Voltage square, so 10 to 20. So 20 square minus 10 square. So let's see what do we get. 6 by 2 is 3. So 3 into 10 to the power minus 6. 20 square is 400. 10 square is 100. 400 minus 100 is basically 300. Okay. 3 3s are 9. and these two zeros will be swallowed by the negative power of 6 and it will make it minus 4. So 9 into 10 to the power minus 4, of course, SI units, that means it will be joules. So it should be option number B. Is that absolutely clear, everyone? This is how you solve it. Choice of the formula is very important because you have three options. You need to check whether charge voltage, capacitance voltage, or charge capacitance, what is given to you. So half CV square for capacitance voltage, half QV for charge voltage, and Q square by C half times for charge and capacitance. Okay, moving on to the next one. There is a parallel plate. This is a previous year question. A parallel plate capacitor of 1 microfarad being charged to a voltage of 20 volts. The distance between them is 1 micrometer. The energy density between the plates of the capacitor is how much? Welcome, Rama. No problems. Join in. Okay. Anyone from IIT Madras? Ritik, you should ask this question after 1 year. Okay. So all of them will be then in IIT Madras or maybe their favorite IITs. Cool. Yeah. So charge to a potential difference. The distance is given. The energy density is asked. Energy density. Look at this. Question is on energy density. So energy density is half epsilon naught electric field square. But the problem is I do not know the electric field. Maybe something else is given for me. I think it is given. The voltage difference is given and the distance is given. And if you recollect from the chapter of electrostatics, potential field, there is a relation between field, potential and distance. And that is nothing but the field is nothing but the negative of the potential difference upon the separation. That was the formula. E is negative dV by dr. But here I am interested only in the magnitude part. So the field magnitude will be, potential difference is 20, separation is 1 micrometer, that means 1 into 10 to the power negative 6. So it will be nothing but 0 into 10 to the power plus 6 volts per meter. That is the magnitude of the electric field. And I'm only interested in the magnitude. Anyways, I'm squaring it. So negative sign will not bother me so much. So this should be as simple as, whatever that value is. So epsilon naught permittivity is nothing but 8.85 into 10 to the power minus 12. And then over here, field square. So if you want, you can write this as 2 into 10 to the power 7 volts per meter. So it will just become 2 square multiplied by 10 to the power 14, because 10 to the power 7 square is 10 to the power 14. So one of the 2's will get cancelled and you are left with 2 multiplied by 8.85 multiplied by 14 and minus 12 will make it 10 to the power 2. So this will become 2 multiplied by 885. 800 into 2 is 1600. 85 into 2, that's 170. 1770. 1770. What will it be? Joules per meter cube. 1770 joules per meter cube. So if you want to write it in terms of one single decimal place, well, it is 1.77 into 10 to the power 3, which can be then approximately said as 1.8 into 10 to the power 3 joules per meter cube. This is approximate after rounding it off to a single decimal place. So that is option A, of course, but exact answer will be 1.77 10 to the power 3. Yeah. All right. Sir, is VIT Bhopal? I doubt, Avinash. VIT Bhopal is quite a far stretch. I mean, if you are getting better options, please go for it. Madras, Vellore, fine. Bhopal, too much of a far stretch. Plus, which branch are you getting? How much fees? Are you a dropper? You have no other option. Can't take a drop. That's a different story. Okay. So, not advisable. Right. Oh, welcome, Ritik. You are also a student of IIT Madras and already cleared. Wow. So, you should motivate your juniors to come into the campus so that next year, yes, you can rag them. Kidding. So next year you can, be their mentor and you would have lovely students from our Vedantu JEE English channel. Already many students are there in many IITs. So glad to see all of you coming back and welcoming your juniors and pushing them. Please push them. Yeah, they need to be really motivated. They need to be really kicked and pushed, to tell them, listen, boss, a lot of things are there. A lot of cool things are waiting for you. Yeah. So just give it your shot. Things happen good. Things don't happen, no problem. Yeah, definitely. Effects of dielectric. Remember, dielectric, we have already discussed what's a dielectric. It's a non-conducting material which reduces the field by some extent, like ceramics, wood, plastic, paper, yeah, water. So if 100 volts per meter of field is entering a medium, and let's say it becomes 50 after entering the medium. So it reduced by a factor of 2. So the dielectric constant of that medium is 2. If that 100 becomes 10, that means you have reduced it by a factor of 10. So the dielectric constant of that medium is 10. So ceramics have very high dielectric constant in the ranges of 200, 300, 400. So that's the dielectric. It reduces the field strength by creating induced polarities inside that medium. We have discussed this in detail in the previous session. Now, what does a dielectric do? Simply put, it just increases the capacitance. Why does it really increase the capacitance? I'll give you a simple example. See, imagine there is a capacitor. Imagine there is a capacitor. Now, when there is some charge stored in it, let's say the field in units is 100 when there is a charge of plus q and minus q stored on it. Now, what I do is the space between the capacitor, I fill it with some medium. I fill it with some medium over here. Some dielectric medium I fill it with. Now, what happens is that the moment you have a dielectric medium, if you had the same charge on that particular capacitor, let's say plus q and minus q, maybe that dielectric constant of that medium, chumma I'm saying, let's say it is 4 or let's say it is 5. Okay, chumma I'm taking some random value. So if the charge is the same, what will happen is that this electric field, which was probably quite strong here of 100 units, it will become weak. In fact, the electric field will no longer be 100. The electric field will be 100 by 5, which will be 20. So earlier it was 100, now it will become 20. Why? Because that's what the dielectric medium does. But this is the best catch in this entire scenario. So the field will try to reduce because of the medium by that factor of the dielectric constant. Think about it. This entire setup, technically, I have connected it to a battery. I have connected it to a battery. So if I have connected it to a battery, that means if it is being connected to a battery, that means the voltage is basically the same. The distance between the plates of the capacitor is also the same. Therefore, voltage per unit distance is also going to be the same. But what is voltage per unit distance? It is nothing but the field. The field has to be the same. Oh my gosh, I'm getting two conflicting answers. This is saying if you put a dielectric medium, that 100 should be divided by the constant, so it will become 20. But the capacitor is still connected to that battery, so voltage difference is the same, the distance between the plates is the same, so V by D is the same, so field is also the same because E is dV by dR. This is saying field is same, this is saying field will reduce. Who is correct, who is wrong? I'll tell you, we'll have to help both of them. So dielectric medium is saying whatever you give me, I will reduce the field by 5 times, okay, or K times. This theory is saying that field should not change. Fine, let's make both of them happy. You know how? It's like saying, imagine our government says Okay, maybe you are in Dubai or something, and there are no taxes, right, in Dubai, right? So you earn $1 million, you don't pay tax, you get home $1 million. Let's say you go to a very highly taxed country, I don't know, Chumma, I'm taking some country, and in that foreign country, the tax is 50%. So if you earn $1 million, you'll only get $0.5 million. You are very unhappy about it. You are like, no, no, I still want to earn $1 million. So what will you do? You will start earning $2 million. So that after the tax of 50%, you are still getting $1 million. So you are still getting $1 million. Understanding? Eventually. But it is after that cut. And if that cut was not there, whatever was given to you was credited into your bank account. Similar thing will happen here. So imagine in this scenario, if I make this charge over here 5 times more and this charge over here 5 times more, so the field will also be, instead of 100, it will be 500. Okay, instead of 100, now it would be basically how many times? It will become 500 without the dielectric. But the moment I add that dielectric medium, what will happen? It has to reduce by K times K over here is 5. So now it will become 100 volts per meter. So the field has not changed. That's what you feel. But actually it has decreased because more charge now is stored. So magically what I have done to just make this dielectric medium happy. Okay, you want to reduce the field, Baba? Okay, no problem. I will store more charge. It's like saying, okay, you are putting more tax on me. No problem. I will earn more. You put more tax, I will earn even more so that I will maintain my lifestyle, boss. I will still earn the same money. So that means more charge will be stored. So this is the concept of a dielectric. How many of you got it? How many of you got it? Everyone? Yeah. Did you love this example? Did you now understand it? So the dielectric medium, so basically a dielectric medium, dielectric medium increases the capacitance, k number of times, So if C naught is basically the capacitance without any medium, then the new capacitance will be K times of C naught. This is with the dielectric medium present inside. Also, just to remind you, all the formulas like capacitance of a parallel plate capacitor. Earlier, we used to write epsilon naught A divided by D, right? Actually, I should put K also because some medium might be present. Same thing for, spherical capacitor. Same thing for our spherical capacitor. It used to be 4 pi epsilon naught 1 by A minus 1 by B. Technically, I should also multiply it with K because if the space between those shells is filled with a medium, then it will increase by K times. So these are the modified formulas in case the medium is present. But otherwise, just remember that the capacitance becomes K times. But keep this in mind, the capacitance will increase K times only and only if the medium is completely being filled between the plates of the capacitor. Like you order for a sandwich and the filling is there everywhere. But what if you ordered for a nice sandwich, the filling is only there on one side. This side, nothing is there. He has just put some butter and given it to you. I'm like, oh, what is this? I was eating the bread from here, but no masala is there. All the masala is on one side. It will be sad. So what if such kind of situation happens? That is your partially filled capacitors. So when you have partially filled capacitors, something like this, observe carefully. This is one plate. This is another plate. These are the terminals. And let's say you're filling it with different materials. Okay, partially filled, meaning it could be different materials also. Okay, and there are some n number of materials over here which are being filled inside of it. And each one of them has different thicknesses like T1, T2, like that, Tn, and dielectric constant K1, K2, Kn, and so on and so forth. And the total thickness earlier was T, area was A. So the old capacitance without any medium, it would have been simply epsilon naught A by D. But with all these things in between, the new capacitance, keep this in mind, very interesting. Okay, let me just write it slightly over here. It is epsilon naught, okay, epsilon naught A divided by, over here in the bottom, you will write D1 by K1 plus D2 by K2. Like that, whatever number of slabs are there, that many terms will come. Last term will be Dn by Kn. Sorry, distance instead of that, we can also put thickness. My bad. Sorry, I've used T symbol. So T1 by K1 plus T2 by K2 and so on and so forth. Last will be thickness N divided by Kn. That's it. So instead of epsilon naught A by D, that D will be replaced by T1 by K1 plus T2 by K2 plus something like that plus Tn by Kn. So each thickness divided by dielectric constant. That is the new capacitance. Don't have to remember any other confusing formulas. Some books give some crazy formulas. Epsilon A K by D minus T, 1 minus K, some weird shit. So don't remember all those things. Just remember this formula. Very easy to remember. Okay. We'll solve the numerical problems also on that. Say for example, then yeah, okay, let's start with this first. There is a parallel plate capacitor. It is made of two plates, each of area 40, separated by 0.4. Material of the constant is 10. And what is the new capacitance of the capacitor? So the capacitance with the new medium will be epsilon naught A by D and K times. Permittivity is nothing but 8.85 10 to the power minus 12. Area 40 centimeter square is the same as 40 into 10 to the power minus 4 meter square, which is 4 into 10 to the power minus 3. So area is 4 into 10 to the power negative 3. Okay. Dielectric constant is 10. The whole thing divided by the distance is 0.4 centimeter. 0.4 centimeter is 0.4 into 10 to the power minus 2 meters, which is 4 into 10 to the power negative 3 meters. So over here, 4 into 10 to the power minus 3 meters. Okay. Couple of things getting cancelled like this one and this one. 4 into 10 to the power minus 3 is getting cancelled. I'm left with 8.85 and minus 12 and 10. So this is minus 11, but I can see pico over here. So why not just do one thing? Swallow the 10 inside. So it will become 88.5 into 10 to the power minus 12 farads. So the power of negative 12 is a pico. So it will be picofarad. 88.5 picofarad is the right answer. Yeah, 88.5 picofarad. Pico is minus 12, nano is minus 9, micro is minus 6, milli is minus 3. Yeah, perfect. Very good. Great. I'm so glad, Ritik, you're motivating all our juniors. Sir, why seen you in partially filled dielectric has such formula though? Sir, can you explain once? Pavi, it comes via the series combination. Actually, all these are small capacitors in series. So there is a small derivation for that also. So from that it comes. Another way of looking at it, imagine this thing was completely filled with a medium. So this would be K. This would be K. which is the same as writing epsilon naught A by the total distance by K, because K on the numerator is 1 by something in the denominator. Now compare this formula with this. This is when entire space is filled with one single medium, the entire distance. So if there are small spaces filled with multiple mediums, so then instead of d by k, it will be summation of it. So d1 by k1 plus d2 by k2 plus d3 by k3, like that. So small distances you can take. So this is another way of looking at it. Is that okay? Yeah. Sir, how many marks should I get in JEE Mains to top NITs from general category? Shin, if you want to be in the toppers, about 250 for sure. Okay, about 250, but things can get ugly or good depending on the level of difficulty of your shift and that year's paper. So it can go as much as 300 out of 300. It can come down to 270, 280 marks also. So there were some famous cases of some cheaters who were toppers. Also, you might have seen that in the last year, some students who got 300 out of 300 by copying, but never got caught, which is very sad, right? So hopefully our students don't do that. And yeah, 250 basic bare minimum, right? Moving on to the next question. See, this is a partially filled dielectric. It is not filled completely in between. As you can see, the separation is 2 meters and the capacitance is 4 microfarad. The new capacitance will be when you fill it with a constant of k is equal to 3, such that half of its space is filled in between, like that. Okay. So first let's solve this particular problem just for the old capacitance, which is C naught, which is epsilon naught A by D. So C naught is basically epsilon naught A by D, which is nothing but 4 microfarad is epsilon naught A divided by D. So when there is absolutely nothing in between. But the moment you place this medium in between, so there will be a new capacitance, and the new capacitance is exactly what is asked. No issues. We'll see what to do with it. So it will be epsilon naught A, the whole thing divided by this D and this D. How much will it be? Well, this is nothing but D by 2. Obviously, this is also D by 2. But this is air. And what is the dielectric constant of air? It is 1. This already given over here, K is 3. So D1 is nothing but D by 2. K1 is 1. D2 or thickness 2 is also D by 2. But the dielectric constant is 3. That is how this works. I'm just using this formula, nothing more, nothing less. Thickness 1 by K1, thickness 2 by K2, like that. There were 2 slabs, you can think of it. Yeah, air can be also treated like a slab, but whose dielectric constant is 1. Correct? Dielectric constant of air is basically 1. Perfecto. Now what do we do with it? Well, solve, guys, nothing more. I mean, what else can we do? So this will be epsilon naught A divided by, this will be D by 2 common, and 1 plus 1 by 3. Okay, so let's see what do we get the new capacitance as. That epsilon naught A is there, D by 2 is also there, 1 plus 1 by 3 is 4 by 3. Okay, take it on the top. So it will become epsilon naught A by D, and 2 3s are 6 divided by 4, or in fact, you can do one thing before shifting it on the top. This 2 will cancel with this 4 2 times. So therefore, 3 goes on the top and 2 stays below. But wait a minute, what is this epsilon naught A by D? Epsilon naught A by D, I just calculated it here. It is 4 microfarads. Oh, so this multiplied by 3 by 2 is the new capacitance. 2 and 4 cancels, it will become 2. 2 3s are 6. So 6 microfarad is nothing but the new capacitance. Yeah, everybody just saw this coming out here. I didn't see it coming before, but when I solved, I reached this point and I immediately realized I can substitute this whole thing for 4 microfarad. Perfect. I substitute and then I get the answer as 6 microfarad, which is option number C, of course. Yeah, option number C. Is this absolutely clear, everybody? This is how you solve the previous year JEE Mains question and partially filled. Yep. Perfecto. Perfecto. Great. Jampani, I hope your doubt is clear. And yeah, Balas, yes, J Eagles, and Ritik is also telling the right thing out there. Correct. Okay. Now, what happens when you take a dielectric, you place it inside or you remove it outside? So there are couple of things that can happen, obviously, and we will see all the different variations. So imagine we have a capacitor whose capacitance is C, some charge is stored, there is some electric field between them. And then what happens is, in between the plates of the capacitor, you add some dielectric medium. You add some dielectric medium. Okay, so you are adding some dielectric medium. So in this process, what exactly happens, we need to figure out. But there are two scenarios in this. What are those two scenarios? One of the scenarios is when there is a battery which is connected to the capacitor when all of this is happening. And the other scenario is when there is no battery connected. So no battery connected, no battery connected versus there is a battery which is connected, battery which is connected. So this makes a hell lot of difference in the answer. Okay, so what are the different things that I want to measure? Let me write it down over here. So let's say these are the old values, and let's say we'll write the new values. I want to see the capacitance, I want to see the charge, I want to see the voltage, I also want to see what will happen to the electric field, I also want to see what will happen to the energy. Same thing I will do it over here also. I will see the old values versus the new values. So I want to see the old values, by the way. Sorry, the old values will be C, Q, V, electric field, and this energy. Same thing over here. Capacitance, charge, voltage, electric field, and the energy stored. These are the old values. We will see what will be the new values now. Okay, ready for this game? Ready for this game? So let's start. First, with the capacitance. No brainer, the moment you add a dielectric, the moment you basically add a dielectric, the capacitance has to increase k times. So in both the cases, capacitance will become k times of C. Here also it will become k times of C. That is the first thing that you can conclude. Perfect. HCV is for theory and standard problems. DC Pandey is for additional problem practice. Although the theory is there, but not so deep. And H.C. Verma explains it from the basics in a beautiful way with the standard questions. So to get to some level, you need H.C. Verma, but beyond that, obviously, you will need other books. Okay. Now, what's the difference when there is no battery versus battery? Here is the difference. When there is no battery connected, the charge on it has no place to escape. So this particular charge will still stay as it is. So it is the charge which will remain the same because it has no place to escape. No place to escape. But when the battery is connected, the battery can supply the charge, it can move it around, but the battery maintains the voltage. So it is the voltage which remains the same. So the battery will maintain it. Battery maintains the potential difference across the capacitance. From this, we can understand because Q is C into V, charge is capacitance into voltage. Capacitance increased, so that is why the charge will also increase K times. So it will become K times of Q. Reason for that is because Q is equal to C multiplied by V. So if capacitance increases K times, the charge should also increase K times only. Is that right? What about over here? In this case, think about it. Voltage is charge divided by capacitance. So the capacitance increases K times, charge has not changed. So the voltage should change by 1 by K times. So 100% the voltage will now become V by K. Yes, it will change by a factor of 1 by K. That is what will happen. Charge will increase here K times. Here voltage will decrease by K times. Is this logic absolutely clear, everyone? Everybody? I'm happy for you. Thank you so much, SSB. Perfecto. Absolutely clear, my dear students. Okay. What about the electric field? Which formula do I use? Electric field is voltage by distance. Electric field is voltage by distance. So when battery is there, what if I use electric field is voltage by distance. Distance didn't change, voltage didn't change, so field will not change. So field will remain the same if I use this, because both are the same, battery also and the distance between the plates. But over here, voltage has changed, and since electric field is voltage by distance, distance is still the same, but the voltage has become 1 by K times. So the field will also become E by K. The field will also become E by K. So if it was 100, it will become 100 by K. What about the energy? Here charge was not changing, capacitance was changing. So here if I use energy is equal to half Q square by C, capacitance has become K times, it is in the denominator. So energy will become 1 by K times. So energy will become U by K. Energy will become U by K. Whereas in the case of battery being connected, voltage is constant. So why not use energy is equal to half CV square. Capacitance increased K times. So energy should also increase K times. So the energy will become U times of K, or K times of U. That's it. So this is what happens when you add dielectric. When you remove the dielectric, exact reverse will happen of this. Is this clear how to do the analysis? First, see whether the battery is connected or not connected. If battery is connected, then the potential difference across the capacitor will be maintained. If there is no battery connected, charge will be maintained. Based on that, you can do the rest of the analysis. For energy, you need to see what is constant, accordingly change your formula. When charge is constant, make sure you keep charge in the formula, because the analysis will become easier. Half Q square by C. When voltage is remaining constant, use half CV square, because voltage is same. So capacitance will change K times. So accordingly, you can adjust and manipulate what will happen to it. For field, use voltage by distance, and for rest of the things, use Q is equal to CV. Is this absolutely clear? Okay. Sir, what is the meaning of EJEE? EJE means, see, J was offline, no, long time back. So E means electronic. So EJE means electronic JE. So like you have E-Aadhaar card or some electric, EV. V means vehicle. So EV means electric vehicle. So it can also mean electric JE also. Okay. Right. So it is the digital version of JE or electric version of JE. So sometimes you might get some electric shocks when you are sitting at the center. Sometimes the shocks can come because of the question. So if you get an electric shock, so it will become EJE. Okay. I hope you understood what is the meaning of EJE. Right. Okay. Right. Say about preparatory courses at IIT. Oh my God. That's a topic in itself. Well, I need to make a video for it then separately. Okay. How about this question? A parallel plate capacitor is there. A parallel plate capacitor is there, and some medium is filling it. It's charged to a voltage and isolated. Then the dielectric slab is removed. Another another dielectric of equal thickness, but medium is different, is placed in between. What is the ratio of the energy stored between before versus later? Okay. We didn't have percentile, man, that time. Yeah. Pratyush, that is not enough for sure. For JEE Advanced, you need to go a level higher. JEE Advanced these days is not just DC Pandey level or HC Verma level, it is way beyond that. So for mains, it is more than enough. JEE Advanced, you might probably get just qualified, but or maybe okay rank. But if you want a good rank, then you need to practice really good level questions. All right, fine, Shubha. I'll make a video. Right. Okay. So what do we do? What do we do over here? See, we have a parallel plate capacitor and some medium is filling in it. So let's say this is what it is. The dielectric constant is 3. Okay, it is filling in over here. And now you remove that particular medium and now you fill it with another medium whose dielectric constant is 2. So ER means relative permittivity. So don't get confused between these terms. So ER is nothing but relative permittivity, which is the same as your dielectric constant. So you don't have to worry about it. Okay, it is the same as the dielectric constant. All right. What will be same in both the scenarios is because that it is isolated, meaning the charge in the system is conserved. The charge has nowhere to go. So whatever charge was here, the same charge will be here. So I prefer using half q square by c formula. So here initial energy will be half q square by c initial, and here the energy in the second scenario, okay, this was first scenario, it will be half, charge is the same, and final scenario. Okay, so if I take the ratio of both of them, which is u1 by u2, well, half q square, everything is same. Here I will get C1 below and here I'll get C2 on the top. So it will be C2 by C1. But wait a minute. I know one thing, that C2 by C1 will be permittivity multiplied by, or the dielectric constant multiplied by that capacitance which would be there without any media. So if that capacitance is C0, so this will be C2 will be nothing but 2 times of C0 and C1 will be nothing but 3 times of C0. C0 will cancel. So U1 by U2 will be 2 by 3. But they have asked later to initial, means U2 by U1. So U2 by U1 will be 3 by 2. So 3 by 2 should be the answer, not 2 by 3, 3 by 2. Yeah. So that is the answer. So they ask the ratio of the energy stored later on to the initial one. So U2 by U1 they have asked. So therefore it will be 3:2, which is nothing but option number C. Absolutely clear? U1 by U2 will be 2 by 3. Okay, perfecto. I want to crack JEE Advanced. What should I do now? Sujit, if you want to crack JEE Advanced next year, don't wait for 1 year to join a batch. You already have the pro batch. Okay, it's a dedicated batch for JEE Mains Plus Advanced. This year you complete the 11th syllabus on time, and next year you complete the 12th standard syllabus. Okay, and the 12th standard syllabus also we start by March, April types, so that we get good enough of time to complete a syllabus by October and start with the revision and then the final mock test in Jan, so that you are thorough and clear through JEE Mains first attempt itself. So I would advise, do not wait for a year to join a batch or to start your preparation or just prepare from YouTube. Start your preparation right away, right now, because the competition is intense, right? And the level of difficulty of the papers are also increasing. Okay, perfect. Right. Okay, right. Now going on to the next question, but this question you have to solve it as a homework. Where will you give the homework's answer? In the comments after the video ends. So, but how do I know whether it's correct or wrong? Don't worry, you will get the PDF. Where is the PDF? It will be there in the description after the video ends, after a couple of hours. So you can see the solution, the answer key, everything. The previous year paper question, it's a beautiful question on similar concept. You have some medium which is there, battery it is there, it is connected across it. So if you put a slab, then what will be the new energy? So if you have paid careful attention to what happens when the battery is connected and what happens to the energy. So I think if you understood it here, 100% you will be able to solve this question also. Okay, so make it a point that you are writing the answer. Don't take it very easy or say, oh, I know the answer, I got it. Put it up in the comments. I want to see your names, okay, so that we can see it next time. All right, let's do a numeric type of question which is asked in 2024 31st Jan shift. Okay, a parallel plate capacitor with a separation of 5 millimeters is charged by a battery. It is found that on introducing a dielectric sheet of some thickness, keeping the battery connection intact, the capacitor takes 25% more charge from the battery than before. The dielectric constant of the sheet is how much? Read it again and again so that you get an idea what exactly is happening. So, parallel plate capacitor separation is 5, is charged by a battery. It is found that on introducing some sheet of dielectric, it takes 25% more charge from the battery as compared to before. So, if you see initially what will be there, you will have a capacitance, okay, and let's say this particular distance is given to be 5 millimeters, the area is A, and let's say the charge on it is Q. Okay, and then I can say Q is equal to capacitance into voltage. Okay, and while the battery connections are intact, that is also mentioned. Capacitance is epsilon naught A divided by D. D is basically 5 in millimeters. Let's keep the units as millimeters. Let's not change it, okay, throughout the problem. So that thing I know for sure, everything is in millimeters. If I have to use this formula again, I will keep it in millimeters only. No harm in that. I can choose my units as long as I maintain that consistency. Then the second scenario, you are placing a sheet of thickness 2 millimeters, meaning in that particular capacitor, there is some dielectric medium and that is only there for 2 millimeters, whereas the rest of the 3 millimeters, there is air, and air has a dielectric constant of 1. This has a dielectric constant, I don't know. Oh my god, that is what I had to figure out. This is just like using that formula which I have given you over here. Second, where is it? Just gave the formula, right? This one, yeah, this one. If partially it is filled, then what do you do? So in the denominator, you will have T1 by K1's summation. Okay, fine, sir. So let us use that. So the new charge will be the new capacitance multiplied by the same voltage. Mind it that the battery connections are intact. That means the voltage is going to be the same. Voltage is going to be the same. But the new charge is 25% more than the previous charge. What does this mean? The new charge will be the old charge plus 25% of Q. 25% means 1/4. So it will be nothing but 5Q by 4. 5Q by 4. So this new thing will be 5 by 4 times of Q. New capacitance will be epsilon naught A divided by distance is 2 divided by K, which is unknown, plus distance is 3, K is nothing but 1. This all things again in millimeters, of course. And of course, we have voltage over here to multiply it. Wait a minute, I can see Q over here. Q is epsilon naught AV by 5. So why not substitute it? So maybe I will take another slide for this. So we have over here 5 by 4 and then equal to 5 by 4 and equal to epsilon naught A by K, sorry, not K, 2 by K, 2 by K, 2 by K and plus 3, 2 by K plus 3, and there we have V. And on the left hand side, this charge, I replace it with this number, epsilon naught AV by 5. So epsilon naught AV divided by 5. Why did I replace this? Because now it will be easier to solve. As you can see over here, a lot of things are definitely getting cancelled, like epsilon naught AV, epsilon naught AV. This number 5 and this number 5. Flip it and bring it on the top. So this will become 4 is equal to 2 by k plus 3. Therefore, 4 minus 3 is 1. 1 is equal to 2 by k. Therefore, k is nothing but 2. So the dielectric constant is the number 2. This was a numeric type of question. It's just about identifying the two scenarios. See what is same, what is changing, how it is changing, by how much it is changing. Writing Q is equal to CV formula and also using the capacitance of a partially filled dielectric formula. Rest is maths. Okay. Okay, great. Right. What's the difference between YouTube classes and Sigma batches? Amina, see, dedication is obviously the same. It's not like we differentiate that, oh, YouTube I have to put more or less, or Sigma I have to put less or more. Nothing like that. The point of the Sigma batch versus YouTube batch is that, see, when you have a schedule and when you have paid for something, and when you have assignments coming in and you know you have deadlines for that, and you know that there is a test coming, you know that there is somebody watching your results, you know that other students are there in the same batch who are working hard, and you are seeing their discussions, you are seeing their names on the leaderboard, you are seeing on the Telegram groups discussions, doubt solving, teachers are helping, whatever, everything is happening. That's what pushes you ahead in that competition. Okay, so some students might naturally be more competitive without even somebody pushing, pulling them, or any kind of third party intervening. But 99.99% of the students need that push, need that environment, need that targets, need that schedule, need that flow. Nobody wants to use their brain on thinking, what should I study today, which chapter. In a batch, I know today chapter number 5 is taught, I have to study chapter 5. Chapter number 4's test is there, I have to prepare for chapter 4's PYQ's study material problem solving. End of story. You don't have to use your brain. So you are already in a train which is moving. Okay, you don't have to think, oh, how should I go, where should I go, which mode of transport to take, nothing. That's the main difference, right? Cool. Awesome. Sir, இப்படி இருக்குங்க ஸ்ரவணா ரொம்ப சுலபம் and oh sorry, I'm very good, and by the way, I'm coming to Chennai on Sunday evening. So although it is a neat event, but I will tell you a secret, I will spare some time for you guys if you are coming over there. Okay, so I would love to interact with you guys in Anna Nagar Center, Vedantu Learning Center, Anna Nagar. I will be there, okay, this Sunday 6th of July, 6 o'clock, 6th. Okay, I'll be seeing you there. Perfect. All right. Now, before going ahead, there is one more thing which we need to go back and discuss. And this is also very, very important. When we discussed about energy stored in a capacitor, a lot of students think that the battery supplies all that energy which is stored inside the capacitor, which is definitely wrong. Okay, and I want to show that to you. Imagine this is your capacitor and this is your battery, and no matter which wire you take, there is always some kind of resistance of that wire. So this is my battery of some voltage V, this is capacitance, this is some internal resistance or some wire resistance, whatever it is. So when the capacitor is charged, when the capacitor is charged, the energy which is stored in it, is nothing but half C into V square. That is first thing. Next important thing is, what is the work done by the battery? What is the work done by the battery? You might be wondering, why the hell is battery doing work? Well, do not forget, there is chemical energy which is stored in the battery, which is converted into electrical energy while supplying the charge. The battery supplied the charge, so chemical energy got converted, those electrolytes reacted and ions formation, everything, and current was produced. So an electrical energy was produced from chemical energy stored in it. This will be how much ever charge was supplied multiplied by the potential difference. That's the standard formula. Work done by voltage difference is how much charge you are moving through that voltage difference. So the charge that I am moving is the charge which is stored on the capacitor, which is Q. Voltage difference is V, but wait a minute, Q is nothing but CV itself. So this will become CV square. So this is the work done by the battery. This is the energy which is stored in the capacitor. Now there is a problem clearly. Battery did CV square work. Capacitor stored half CV square. It's like saying you gave some Pandu 100 laddus and the Pandu says, sorry, I have only 50 laddus. You are scratching your head now. I gave Pandu 100 laddus, CV square. Pandu is saying, I have stored only 50 laddus. And you are scratching your head for what? Where did the remaining laddus go? Where did the remaining energy go? 100% it would have been lost. Pandu has played some kind of trick with us. So there is some heat which might be developed, some energy which might be lost in that resistance. Any wire you take, some resistance will be there. So definitely there is some loss of energy. So the loss of energy is half CV square. Now the math seem mathing. Like I can say that the change in the energy of the capacitor, or I can put it over here first, the work done by the battery, is how much ever the energy changed in that capacitor plus whatever amount of loss was there. So this was CV square, this was half CV square, this was also half CV square. Half CV square plus half CV square will become CV square. So this is how the equation is. So 50% of the energy is lost when you charge a capacitor. Battery is giving 100 joules, energy stored in the capacitor is 50 joules. 50 joules gets lost while storing that energy. Is this absolutely clear? Yeah. So a lot of students might not love this because, sir, 50% loss. It's like saying I put in 100% efforts, but the marks I'm getting is 50 percentile. Sir, I'm studying for 100% in CBSE board exam, but I'm getting 50% marks. It is very hard to digest. Sir, I'm feeling very bad, sir, for this capacitor, or I'm feeling this capacitor is one country fellow, sir. Full evil, sir. What is this? I mean, battery power, sir, is doing 100% work. Capacitor is storing only 50%. But that's how it is. We cannot do anything. Yeah, that's all. Okay, perfect. Now, let's go back to our combination of capacitors. Back to over here. Yo, combination of capacitors. You have multiple capacitors arranged one after the other, and the one terminal is attached to the next terminal attached to the next terminal. That is basically your series combination. The other arrangement possible is parallel combination. All the terminals on one side are bunched, connected to one terminal of the battery. All the terminals on the other side are bunched together and connected to the another terminal of the battery. This is parallel combination, of course, and this is nothing but your series combination. So what is the difference in series versus parallel? See, in parallel, it becomes actually very obvious to see that whether you take this capacitor, or this capacitor, all of them will have same voltage. This is connected to positive, this is positive, this is also positive, negative, negative, negative. So positive, negative, positive, negative, positive, negative. So basically, it is the potential difference, which is V, is going to be the same for all capacitors in parallel circuit. Is that right? Potential difference, like you might have studied in 10th standard, resistors in parallel, voltages, potential differences are the same. But if you take capacitors in series, then just like for resistors in series, current flowing is same. Here the charge on all of them is the same. So it is the charge, is same for all the capacitors in series. This is very, very important. Okay, everyone? Here, because the charges are same and capacitances could be different, each capacitor might have different voltages. More charge, more capacitance, less capacitance, accordingly voltages will also be different. So if you measure the total voltage over here, the net voltage will be voltage of 1, voltage of 2, voltage of 3, like that. How many ever capacitors? So it will be V1 plus V2 plus V3 and so on and so forth. Is that right, everyone? Depending on how many ever capacitors are there. But when it is in parallel, then if you see all these charges on the left hand side, if I add them together, that is the total charge on a singular plate had it been there. So what is the total charge supplied by the battery? The net charge which has been supplied by the battery, it went here, here and here. So the total charge, if I say it is Q, it is the sum of Q1, Q2 and Q3. Is that right? If more capacitors are there, then Q4 will also come. So for parallel, the charge gets distributed. For series, it is the voltages which get distributed for the total voltage. Clear till this point? Give me a thumbs up, everyone. Sir, is the loss of energy due to collision of electrons? 100%. Yes, the collision of electrons, resistance, that's what creates that loss of energy in the form of heat. Yes, Rama, definitely. Sir, if you reverse any one of the capacitor's polarity, what will happen in each case? Yes, so that's a very interesting thing. Just hold on for some time. We are doing some questions like that, where we connect a capacitor to an uncharged capacitor. We connect a capacitor, let's say, to a charged capacitor of the same polarity or reverse polarity. So all those things we can do. Just give me some time. Yeah? Pavi? All right. So now, coming back to our series combination, what is V1 and Q and C1's relation? Q is CV, so V is Q by C. So technically V1 is nothing but Q by C1. Similarly, what is V2? Q is CV, so V is Q by C. So this is again Q by C2. This is Q by C3. What is this total voltage? The total voltage will be the total charge, which is anyways going to be Q only. And if I replace all these capacitors with one single capacitance, that will be CS. So this is your net effective capacitance, CS. Best part is Q got cancelled. So I am left with 1 by CS is 1 by C1 plus 1 by C2 plus 1 by C3 and so on and so forth. You can obviously make this formula big if there are 100, 200 capacitors, right? Many terms will come like that. And interesting thing is, capacitors are in series, but the formula is looking like resistors in parallel. So it's exact opposite. Huh? For resistors in parallel, this is how the formula looked like, 1 by R1 plus 1 by R2. But actually the capacitors are in series. So no points to guess. For capacitors in parallel, the formula will end up looking like resistors in series. Let's try it out. Q is nothing but this charge is capacitance into that voltage. So it will be C1. It will be nothing but C1 into V. This will be C2 into V. This will be C3 into V. This will be Cp into that same voltage. If I replace all these capacitors with one single one, this is the net effective capacitance. The net effective capacitance. As you can see very clearly, voltage, Voltage has just got cancelled, and I am left with Cp is equal to C1 plus C2 plus C3. Oh my god, that's it. Cp is equal to C1 plus C2 plus C3. Perfect. We got it. Amazing. Amazing. Isn't it? Okay, perfect. If you have dielectric in any capacitor, can we determine the side effect of the net capacitance? Yes, why not? See, imagine one of the capacitors had a dielectric. Then C2 will become K times C2, or C3 will become K times C3. That's it. That's the only difference. If in this also, one of the capacitors had some medium in it, then one of these terms will be KC2 or KC1 or KC3. Or if all of them have dielectric, KC1, KC2, KC3, all these terms will come. That's it. That's the only difference. Now, also remember, let's take some special cases also. Uh, two capacitors. No, this is series, right? We don't need two capacitors. Let's say all capacitors are C, then what will happen? If all the capacitors are C, then what will happen? So imagine this. All the capacitors are C, then the net capacitor in series will be nothing but 1 by Cs is equal to 1 by C plus 1 by C, like that, n number of times. So this is as good as saying n by C is 1 by Cp. So, sorry, not Cp, Cs. So therefore, Cs, take reciprocal, will be C by n, will be C by n. So if I have 5 capacitors in series, it's just like saying example, you have 5 capacitors of 20 microfarad in series, then what will be the net capacitance in series, guys? Just think about it. What will be the net capacitance in series? Think about it. You take any one capacitance, which is 20 microfarad, and divide it by the number of capacitors. So that will be nothing but 4 microfarad. That's it. It will be nothing but 4 microfarad. Yeah. Perfecto. Absolutely clear. So it gets divided in series. So in parallel, if you take a special case, if all capacitors are C, then what will happen? Think about it. The net capacitance will be C plus C plus C, like that, n number of times. So therefore, the net capacitance will be n times of C. Just to give you an example of this, if there are 30 capacitors of 4 microfarad each in parallel, then if you want to find the net capacitance in parallel, just take the number of capacitors, multiply by 4 microfarad, 3 4s are 12, so 120 microfarad. That is what the answer will be. Yeah, absolutely clear, my dear warriors. Okay, how this works for series and parallel. Let's solve some questions so that you guys get a hang of it, of course. Here is the first question on your screen. 3 parallel plate capacitors, C1, C2, C3, 5 microfarad each are connected as shown. What is the effective capacitance between A and B? As one can see clearly, C1 and C2 are in series and both of them are 5 each. So if I have to convert them into a single capacitor, what did I just tell you? For series, you divide, right? For series, what did I just tell you? You will divide it. Yeah, for series, you just divide it by the number of capacitors. So in this particular scenario, there were 2 capacitors. So this will be nothing but 5 by 2, which is nothing but 2.5 microfarad. Okay. So now the new diagram will look like this. Between A and B, you have this capacitor and you have this capacitor right over here. This is A and this is B. So this one is still 5 microfarad. This one is 2.5 microfarad. What happens in parallel, guys? What happens in parallel? You have to just add them. So the net capacitance, which is C parallel, you just add them, C1 plus C2, or in this case, what is it? 2.5 plus 5, which is 7.5 microfarad. So the answer is 7.5 microfarad, not 9 microfarad, that is 7.5. Oh, but we have done something over here. Capacitor C1 is now filled with a dielectric of constant 4. Okay, now this was all without a dielectric. So if the capacitor 1 is filled with a dielectric, then obviously things will change. So how things will change? Let's have a look right from the beginning. So this obviously won't be 5. This obviously won't be 5 because C1 is filled with a dielectric of 4. So this will be 4 multiplied by 5. This will be 4 multiplied by 5. So when they are in series, so 1 by CS will be 1 by C1, which is 20, plus 1 by 5. LCM is 20, so it will be 1 plus 4, which is 5 by 20, which is 1 by 4, that is 1 by CS. Therefore, CS will be 4 microfarad. So combination of both of them is nothing but 4 microfarad. Now, imagine this. Since their equivalent is 4 microfarad, that is in parallel with C3, which itself is 5 microfarad. So what is the effective capacitance now? So the net capacitance will be capacitance in parallel. You just have to add them. So 4 plus 5, which is nothing but 9 microfarad. So 9 microfarad will be the answer, provided you have put the dielectric, hence option A. But if the dielectric was not there anywhere, then the answer would be 7.5. Is this absolutely clear how we solved this question? Give me a thumbs up. Everyone, put some fire emoji, guys. And if you have forgotten to like the video, please do it right now. You need to be reminded. Mark your attendance, show your support, show your strength for the #1 J English channel, which is your channel, not my channel. It's your channel for you guys. Okay, we are putting in that effort for all of you so that every student out there who wants to learn from dedicated teachers throughout the year, you have a live class, be it 11th syllabus or 12th syllabus. Best part is a dropper student and 12th standard student can cover all their backlogs by attending the 6 o'clock classes at for 11th standard. Thank you so much, gamer. Thank you so much, Aswin. Thank you so much. Sir, does increasing K will increase the net capacitance in both series and parallel? Not necessarily. Okay, so in parallel, to for sure it will increase, but in series, the formula looks in reciprocal, right? So if you think about it over here for series, for example, imagine earlier you had 1 by C1 plus 1 by C2 is 1 by CS. Now you put some number over here, for example, K. So what will happen? This number will reduce because K will be like 2, 3, 5, 10. So this ratio will reduce. So you are adding a smaller number to this. That means this whole thing will also reduce. Therefore, CS will increase. So whenever you add a dielectric medium in any of the capacitors, this is for series, obviously it will increase. For parallel, though, obviously it will increase because capacitor will become K times. So C1 plus C2 plus C3, one of them increases, the total sum will also increase. So in either of the cases, yes, it will increase. Okay, whether you put the dielectric medium for series or for parallel. The amount by which it increases could be different. Okay, all right. Now comes the next one. Amazing question on your screen. There is a capacitor of 50 picofarad. It's charged by 100 volt. It is then connected to uncharged capacitor. How much energy is lost in this process? Okay, all right. Okay, we are upgraded. Good to know that, gamer. But we have students who are learning right from basics, who have no clue. I'm pretty sure there are a lot of them, right? So that's why we have to keep the pace average. I can't go very fast because I know we have a lot of toppers also, but I can't give it very slow also because then our topper students will be like, sir, you are going slow. So either ways, one student will definitely ask, sir, either go fast or go slow. So I keep it average. Capacitor of some capacitance is charged by 100 volt source. It is now connected to uncharged identical capacitor. So what is the energy loss in this process? Okay. So first of all, guys, we have this capacitor. It is connected to this battery. Okay. Let's say this is V. Let's say this is C. I'm not substituting any values. Right now, there will be some energy which is stored. So I'll call it U1, which is half C V square. Now, talking about the charge on it, this charge which is there, this Q will be capacitance into voltage. Okay, keep this aside. Now what are you doing? It is now connected to another uncharged capacitor. Okay, so you have this capacitor of capacitance C, but it is identical in nature, so you have not yet connected, but I'm just putting another capacitor beside it. So this guy has a charge of plus Q and minus Q. This guy has a charge of 0. Now, the moment you connect it, the charges will get distributed, of course. Yeah, the charge will get distributed and you will see probably something like this. Oops. This capacitor over here and this capacitor over here. This is C, this is C. Charge will get distributed equally. This will be Q by 2 and this will be also Q by 2. Plus minus, of course. Plus minus. Perfect. So now, in this final scenario, how much is the new energy stored? So U2 will be each capacitor, well, half Q by 2 square by C. Q square by C half times is the energy stored in a capacitor. Now, there are two such capacitors. So I will have to multiply by 2 also. This one and this one. So I have to take into account that. 2 cancel. So this will become 1 by 4 Q square by C. But what is Q? Q is CV. So substitute that. So it will be 1 by 4 C square V square by C, which is 1 by 4 CV square. Perfecto. Now comes the last part. What is the loss of the energy? So the loss will be nothing but half CV square minus, this is 1/4 CV square. Half minus 1/4 is 1/4. So 1 by 4 CV square. So now substitute the values. So the best part is throughout the problem, I didn't substitute the values. I was just waiting till the end till I get a formula to substitute. So I got a formula, not necessary to remember, but just telling you. Okay, so 1/4 into 50 picofarad. So 50 into 10 to the power minus 12 and voltage square. Voltage is 100. So 100 square, guys. Yeah, that's what it is going to be. So 50 by 4, 50 by 2 is 25, by 2 is 12.5. So 12.5 into 10 to the power, what is this? 4 minus 12 means 10 to the power minus 8. So 12.5 into 10 to the power minus 8. That is the answer. So I think they have asked in nanojoules over here. So they have put it as 125, but it is the same thing. You can see this will be 12.5 into 10 to the power minus 8, which is 125 into 10 to the power minus 9, which is 125 nanojoules. Is the same thing. Yeah. So we got the answer. Amazing question, isn't it, everyone? Now, let me remind you, there could be many such questions like this. Imagine you have a capacitor which is charged by a battery like this. You disconnect it. Still that charge is there. So this plus minus Q, which is equal to CV. So that plus Q minus Q is there. Maybe you have another capacitor which is charged by some another battery, maybe double the size, maybe 2V, maybe the capacitance is something else, maybe it is 4C, chumma some random value you have taken. So when you have that thing, obviously now the charge will be different. Let's say this is plus minus. This charge, well, it will be 4C into 2V. Yeah, capacitance into voltage is the charge. So it will become 8 times of CV, which is 8 times of Q. 8 times of Q. So if this had Q, this capacitor, which is charged separately of value 4C, will have a charge of plus 8Q over here and minus 8Q over here. Now imagine you connect these capacitors. There are multiple ways of connecting it. Let's say positive to positive, negative, negative, or positive to negative, negative to positive. Reverse polarities also we can connect. So imagine somebody decides that, okay, I'm connecting this with this, and I'm connecting basically this with this. So how will it look like? Think about it. Okay. First of all, this capacitor, like this. Okay. So we have over here plus Q, minus Q. Plus Q is connected to minus 8Q and minus Q is connected to plus 8Q. So eventually what will happen is that these charges will now get distributed. But not in equal amounts because the capacitances are not same. But what will be the ratio? Oh my God, that is a headache. So why not forget them and just treat them like two capacitors in parallel, C and 4C. There are two capacitors in parallel. So the effective capacitance that I will get, if these were two capacitors which I just connected in parallel, what is the effective capacitance I will get? I will get it as 5 times of C. Everybody agrees or no? Yeah? Everyone? Yes, perfect. No need to find the voltage. Think of it like a parallel capacitance. These terminals, they are open-ended. Fine, no issue if I keep them open-ended like this. It's not connected to anything. It's a parallel circuit. So, what will be the new charge over here? Will it be 9Q or will it be 7Q or 8Q? Answer it in the chat box. Think logically. This plus 1 and minus 8 will become minus 7Q. And plus 8 and minus 1 will become plus 7Q. So this is the new total charge on the effective capacitance. This is nothing but effective capacitance. Here I'm opposite polarities are connected. Here capacitors were charged. And then disconnected. And then they were disconnected, and then the opposite polarities were connected. The effective capacitance is 5C, effective charge is 7Q. As simple as that. Yep, perfect. So if at all we have to find the final energy, in this case it will be half Q square, which is 7Q whole square, by capacitance, which is nothing but 5C. That's it. If you have to find the final voltage, the net voltage, Q is CV, so V will be Q by C. So net charge divided by net capacitance. So net charge is 7Q, net capacitance is 5C. So that's what it will be. But Q is CV, So 7 by 5, CV by C. So it will be 7V by 5. So that is the new voltage difference across the capacitances. We can also find the new energy, old energy, though it is very simple, but this is how you do these problems. Is this clear? How to solve the questions? I think Pavi or somebody had asked this question. Yeah. How to solve the questions of capacitors connected to opposite polarity. Same polarity, though it is very simple. Instead of 7Q, it will become 9Q. That's the only difference. You will add the charges. When opposite polarities are there, you will subtract the charges to conserve the charge. That's all. Very good. Perfecto. Now let's solve this last question from JEE Mains 2022. You have two combinations. The terminals are here. The slabs are one after the other. Versus the terminals are here. The slabs are side by side. And ratio of the new capacitances are asked in this versus this scenario. Read it carefully. Okay. So what do you think the first configuration is in? What do you think the second configuration is in? Is it series or is it parallel? Just give me an idea in both the scenarios. 100%. Here you have one capacitor after the other capacitor. Charge will go through one, then to through. It's in series, one after the other. Here, the charge gets distributed here and here. So when it has options to move charge distribution, that is parallel. So this is series, this is parallel, that's it. Now you can solve it very easily. And the options are given over here. So let's start looking at it slowly. First scenario, when you look at the first scenario, which is like this, epsilon 1, epsilon 2, like this, that is series combination. The capacitance 1, oh, I have to use this formula, 1 by C1 is equal to 1 by whatever, this epsilon naught into epsilon 1 A by D. Well, the D will be itself D by 2. D will be itself D by 2. Area will be the same. So D by 2 plus 1 by epsilon naught epsilon 2 A by D by 2. Okay. So a lot of things are common like 2 and D and oops, 1 second, by D, no? So this D will go on the top, right? And 2 will come below. Okay. So this will be D on the top, 2 will come below, epsilon naught epsilon 1A plus D on the top and 2 here, epsilon, epsilon 2 and A. Taking couple of things common like D, 2, epsilon naught and A, I am just left with 1 by epsilon plus 1 by epsilon 2. So which is nothing but epsilon 1, epsilon 2, epsilon 1 plus epsilon 2. That is 1 by C1, 1 by C1. Therefore, C1 will be 2 times epsilon naught A into epsilon 1 epsilon 2, this divided by D because I have taken reciprocal, divided by epsilon 1 plus epsilon 2. That is what I will get. Similarly, do the same thing for parallel. Do the same thing for parallel also. This is epsilon 1, this is epsilon 2, they are separated. The terminals are here. The area will get distributed A by 2 and A by 2. The distance between them will be the same. So the capacitance will be addition of both of them. So epsilon naught into epsilon 1 A by 2 by D plus epsilon naught into epsilon 2 into A by 2 by D. I hope everybody is clear why we are doing this, right? Parallel capacitance is epsilon naught A by D, but permittivity has to be multiplied by the dielectric constant, which is epsilon 1 and epsilon 2 in both the cases. Okay, let's do the math. So C2 will be, a lot of things are common like epsilon naught A by 2D is common, and I'm left with epsilon 1 plus epsilon 2. Epsilon 1 plus epsilon 2. And what is the question? The question is find C1 by C2. Find, they have asked the ratio of C1 by C2. So take this and take that and just divide them. So taking this first, which is 2 times epsilon naught A by D, epsilon 1, epsilon 2, my god, so many things, by epsilon 1 plus epsilon 2, and divide it with this guy, which is epsilon naught A by 2D. And over here, we have epsilon 1 plus epsilon 2. That's it. So from this, obviously, we'll get C1 by C2. From this, we'll definitely get C1 by C2. A lot of things get cancelled, as you can see, like this D, this D, this A, this A, this epsilon naught, 2 and 2 getting multiplied, obviously becoming 4. Obviously becoming 4. 2 into 2 is 4 over here. Epsilon 1 and epsilon 2 are also there. And in the bottom, we have epsilon 1 plus epsilon 2, the whole square. That's what we are getting it as. So, which is nothing but your option number C. 4 times epsilon 1 epsilon 2 by epsilon 1 plus epsilon 2 whole square. That's it. Perfect. We got the answer. Absolutely clear. Nice question which was asked in JEE. If you have K1 and K2 being inclined with respect to square plates, then how to find the capacitance, Pavi? So if such a question comes, I think that is there in HC Verma, if I'm not wrong. You can check it out. I don't remember the question number now, but it is there in subjective exercise. So if at all you have something like this, which is inclined, and let's say this is K1 and this is K2, then you break it down into small capacitors like this. Many such capacitors like this. Imagine so many such capacitors like this. Okay. And if you take any one such capacitor, you will see a part of it is K1, a part of it is in K2. These are two capacitors in series. You assume that the width of them, you assume that this particular width is basically dx, and these two capacitors are basically in series, and their combination is in parallel. And how much is this length and this length will depend on the equation of this line. So if at all, let's say you know this particular length, and let's say you know this particular width, okay, then you can easily say for a distance of L, the width is d. So if this particular this much distance is x, how much will this particular y be? Like y by x will be just like d by L. Similar triangles, y by x will be d by L. So you get y as a function of x from here. You get y as a function of x, which is d by L into x. So once you know this much is d by L into x, obviously the remaining will be this minus this, which is d minus dx by L, which is the same as saying d common 1 minus x by L. Now you know the length of each capacitor, you know the width of each capacitor. These two capacitors are in series. Find the capacitance. So you will be able to find d capacitor of series. Okay. And then many such capacitors are there side by side. So therefore, the net capacitance will be the sum of all those capacitors. So the sum of all the capacitors in parallel to each other. All these are side by side to each other. So sum means integration. So integration of all this DCS. So when you do it, you will get the answer. Yeah, I hope you understood how I converted a two variable problem into a single variable problem. I know you guys were thinking, sir, y and x will be there, but you can easily find by similarity of triangles. Height by base is height by base, so converted into a single variable. So y is not even there in the answer. Is this absolutely clear? Yeah, perfect. All right. Tattva, is it enough for CBSE? But solve PYQs also and practice a lot of mock tests. It's not just enough, practice more, my dear. Never is one book enough unless you practice PYQs and some extra questions, assignments, teacher questions, mock tests, any exam, guys. Don't be just dependent on one book. Yes, follow one book, master that book, but also go beyond it and solve mock tests and PYQs and class questions and assignments and DPPs. That is obviously needed. Yeah. So today's homework question already given to all of you out here. Where is it gone? Where is it gone? Somewhere I gave it to you. This one. So solve this homework question, take a screenshot, put the answer in the comment section. Of course, we had lovely time today on the energy of capacitors, combination of capacitors. And next lecture, we'll be starting off with current electricity. After current electricity, in between only we'll see how can we use the concepts of current electricity for solving capacitor question. You will see many questions of resistors are very similar to many questions of capacitors. Wheatstones in resistors, Wheatstones in capacitors, equivalent formulas here and there. KVL and KCL, Kirchhoff's laws, can be applied to capacitors also, for resistors also. That's the reason why we did capacitors first. Now once we do current electricity, we can use whatever we know from capacitors over there. Okay, so this capacitors will get continued in combination with resistors and batteries in current electricity. Cool. So, but we'll start with current electricity in the next class at 8 o'clock, right? Thank you so much. If you've forgotten to like, please like, and do not forget to subscribe as well. This was your Captain Shreyas. Bye bye. Good night.